So earlier we were talking about equilibrium. So if we think of A and B reacting to give us C and D. So we finished off by saying that we don't usually stop at 50-50 ratio. So 50% reactants, 50% products, and if we did, it wouldn't be much use to us. If we want to produce something, we want to produce it at a much higher yield than 50%, only half the possible. And so what we can do is we can change different factors.
Josh, I'm losing the will to me. Do you want to live in the
We can change various factors to affect our equilibrium position. And so our equilibrium position can shift either to the right or to the left. And it's all based around this Le Chatelier's principle. And if you learn that, if you have that in your head and are able to apply it, then you're absolutely sorted for this topic. Okay, but it's getting it in your head and deciding what it really means in practice. So, what it says is, if we change a system, if we say, for example, increase the temperature or increase the concentration of something or increase the pressure, if we exert a change on a system, then what the equilibrium will do, it'll shift either to the right hand side or the left hand side in order to minimise the effects of that change. And we talked about that in the example of our esterification earlier on. So Le Chatelier's principle states, and you should learn this, it states that if a system, yep, if a system is in equilibrium, what does it mean if something's in equilibrium? What's equal?
Or balanced. The products and reactants are same amounts. Keep reacting together, but there's only half and half.
Okay, yes, there's a difference between the dynamic part and the equilibrium part. Dynamic is where the rate of the forward reaction is equal to the rate of the backward
reaction, in which the amount of each reactant for its product remains constant.
Yes, great. So if a system is in equilibrium and is subjected to a change, dun dun dun.
Santander. Do you ever see that one, Lee Evans? It's a funny thing when I was
and is subjected to change, the system will rearrange itself. To minimise the effect of that change. So there's three things at the bottom of the page. When you're asked to explain, basically you'll be given an equilibrium equation, and you'll be told that either the temperature increases or the concentration of something has increased. And you need to state what direction the equilibrium moves. So that's the first thing, whether it moves either to the right or to the left. And you have to say why it moves, and that's according to Le Chatelier's principle. And then the third thing is to say whether the yield of your products increases or decreases. So which direction would the equilibrium have to move in order for your yield to increase?
Right.
To the right. And if it moves to the left, then your yield decreases. Excellent.
But surely it's not equal, then. You know what I mean? Like, you know what I mean? Like.
It re-establishes equilibrium. That's the whole point of what it'll do. It'll get there. Okay, let's move on to the effect of. So we'll take the effect of concentration, the effect of pressure, and the effect of temperature separately. So concentration, first of all. And we've talked a little about this in terms of our esterification. And in fact, we'll just revisit that for just a second. So we've got our, for example, our ethanoic acid plus our ethanol gives us, what do we call our ester?
Pardon?
What do we call our ester?
As
Ethyl ethanoate. Great.
water.
Okay, and our sulfuric acid, which is our catalyst, comes in and does what?
Removes the water.
Removes the water. So am I increasing or decreasing my concentration of water?
Decreasing.
So I'll put an arrow down, it's decreasing the concentration of my water. So what direction is my equilibrium going to shift?
Right.
To the right.
To the right. So my, basically, Lucioli's principle, if an equilibrium is subjected to a change, that change in this case is the concentration of my water, which is one of my products. So I am changing the concentration of one of my products by removing that water. Okay, and the principle states that when we have that change, the system moves in order to try and minimise that change. And that's why we see a movement to the right-hand side, because we want to minimise the loss of water, essentially. And so that's why the equilibrium is pushed to the right-hand side. And does that increase or decrease our yield?
Increases.
Increases.
So why does it actually do that? Why does it want to minimise the change?
Because it's happy in an equilibrium. Equilibrium is like the steady state, like... So the example that's in your notes is about carbon monoxide.
You know what I get, like, why does yield increase if you remove stuff from the right? Like, I know what you mean. What, in relation to principle, I get it per se.
Uh-huh.
But I don't get it because you're removing stuff to the end more stuff.
No, but you're not removing it. You're removing the other thing that would.
Oh, you get more. Oh, you're missing the boards away there. Oh, never mind. You get more like. Oh, you mean by yield you get more the ester?
Oh, yeah, because that's what we want.
Right, right.
You're saying move to the right. What do you mean?
As in, my equilibrium will now look like this. So the forward reaction, the rate of the forward reaction will increase until my equilibrium is re-established. And my equilibrium is my concentration of reactants is equal to my concentration of my products.
I thought done like a ratio or what?
Pardon?
Like 1 to 1 or what do you? How do you?
Yeah, it depends on the ratio of your balancing numbers.
Is that how you do it, like?
We'll see that more when we come to pressure.
Okay.
But it's all about seeing a change and trying to minimise that change. So I've got carbon monoxide reacting with chlorine to give me...
What change is there? What was the change?
The change was I removed water, and so I decreased the concentration of my water within the reaction mixture
Less on the right hand side, so move more over here. Make it more.
because it wants to produce more water. Okay, so carbon monoxide
So
reacts...
producing more water, you automatically produce more ester stuff.
Yeah.
I get it.
Yeah. So reacting carbon monoxide with chlorine to give me carbonyl chloride. Okay, and so say for example we decide to increase my concentration of chlorine. Okay, I've now got more chlorine in it. I've disrupted my equilibrium. Okay, it was happy the way it was, but I've chucked in some more chlorine. So I've increased the concentration of chlorine, and how we represent the concentration of something is by putting it in square brackets. So it'll appear that way in your notes. It says if bracket Cl2 increases. So you might want to make a wee note that that means concentration.
This is like that water thing, chlorine water, you know, the BO.
Yeah, no, it's not an oxidizing agent.
It's got to be brackets, don't it?
Yeah, concentration of Cl2. You might want to write that in, that that's what that means in square brackets.
This can move over with it.
Yeah. Okay. So if I increase the concentration of chlorine, what's my equilibrium going to want to do?
Move to the right.
It's going to want to move to the right. Why?
Because there's more reactants.
And so what's it trying to do?
Balance it with more products.
Yeah. Okay. So again, our principle, this is Chile's principle, tells us that
Should we just
when
like abbreviate to like less or something?
LCP.
Less.
LCP states that when I've subjected my equilibrium to a change, and the change in this case is increasing the concentration of my chlorine, the equilibrium shifts to try to minimise that change. Okay, and it minimises that by that change by using up my chlorine. Okay, so if I've added more chlorine in, then the equilibrium, it wants to use up that extra chlorine, and so it does that by reacting it with my carbon monoxide to produce my carbonyl chloride.
How can it use all the chlorine in the reaction if it's in excess? Surely the carbon monoxide would run out first.
Nifty.
Yeah.
She's got you there. Or he's got you.
Say it again, sorry.
So you see the way, so the chlorine's in excess now.
Yeah.
How would that even change? How would that even change the amount of product produced if it's only COCl2 if it's in excess? Because they can only react with CO.
But you would have some spare CO sitting around there because remember it's in equilibrium.
No, because surely all the CO will
Yeah.
be used and then.
You'll have more CL2.
No, because
Your,
you're only left with
your
CO2
products, your reactants and product are balanced on outside, so you'll have like
Yeah, but if you have more CL2, surely that like means there's more CL2 than CO. Otherwise, you have to have more CO as well.
in there, but
You know what I'm saying? Like,
You've more CO2 than CO. Yeah. And so then if you're thinking about it, it's in equilibrium. That means the concentration of the reactants equals the
Yeah, but once you
concentration
have
of the
CO2
products.
extra
Yeah,
something
then
there.
it's going to use up some of that carbon monoxide. Yes.
But if there's more CO2 than CO, then surely they'll end up a bit more CL on the side. If you know what I'm saying?
Standard for you.
So you can't make more.
But you will be able to use those carbon monoxide molecules that are sitting around.
But
In the
why
equilibrium.
would there be any sitting around? If you know what I'm saying?
Because it's
there's
in equilibrium.
It's like in equilibrium. Half the reactants are still there and half the products are still there. So you still have CO on the left. It
Yeah,
just
but
doesn't
not-
want to. It doesn't want to react because it wants to remain half.
But surely with
But
extra CL.
putting the CL2 in disrupts that half distribution.
But say you've got
Therefore, it wants to
50-50 COCl or COCO on either side. Once you add more CL, will not become like 45-55 CO? Extra because of the extra CL. You get me? Like,
The chlorine's going to increase in concentration. So that's going to
yeah,
be...
no, but there's more CL, yeah. So that means more CO has to react. Say you've got 50-50 COCO.
Mhm.
Because then maybe 45 on this side and 55 on the other side per se. Because you're reacting with more chlorine.
Yeah, because
Okay,
the equilibrium shifts to the right hand side.
Yes,
Yes.
is that right?
Yes.
Oh, okay.
Okay, I think. Anyway, if you keep the LCP in your head, once you've got a change, you're trying to minimise the change. It's literally, that's all you'll have to do with it, is take it that far. So, what happens if I then decrease my concentration of chlorine?
It'll all go to that.
Yeah, it'll go to the left because my equilibrium is now disrupted. I've got less of my chlorine, and so my system wants to make more chlorine to replace that I've removed, and so the equilibrium shifts to the left. What does that do to the yield? It decreases the yield. Okay. Okay. So having a look at those little statements there. So if we increase the concentration of our carbon monoxide, the equilibrium position moves to the
Left, right.
right. Good, because it wants to remove those excess reactants. So write in right, and then write in what that does to the yield. So what does it do to the yield? It increases the yield. Moves it to the right and it increases the yield. What happens if I increase my concentration, if I chuck in some carbonyl chloride?
The vice versa per se.
Yes, which would be
Left.
the left hand side. And what result does that have in the yield?
Sure, then it'll still increase the yield.
No. It's an
Because you've got
You've
more.
got- yeah.
Yeah, I get you. But then
It pops over there.
the stuff you've added in, the carbonyl chloride that you want, it's going in the reverse reaction, is actually breaking down to carbon monoxide and chlorine.
You know the way it's.
It's completely pointless.
Yeah, it's just
I mean, you wouldn't do that
Still
for.
increasing the yield that you have from the reaction.
No, because the extra stuff that you chuck in breaks down to produce this.
But you still have, in the end, you still have more on that side than you originally did.
You see the guy in Cali, he's
You would.
tall, like
You would, you
Oh, my juice.
But you haven't produced that. Yield is the stuff you've produced. Okay.
Surely the yield is the same then.
Hmm?
Surely your yield is the same then as well. Or you're just wasting stuff that you already have.
The equilibrium shifts to minimise the change.
Seriously?
That's what I'm sticking with. I'm sticking with LCP. Okay. Rowdy's in the corner. if I decrease my concentration of carbon monoxide, what's that going to do?
Move to the left.
Move
How
to
do
the
you make
left.
something unreversible? How do you make it unreversible?
You can take out the thing that's made with the product. Like if you take out the water there, it can't go back to its original state. It doesn't have water to react
But
with.
then you just add in water again and it's
So
reversible.
to make it unreversible, you just remove
So
something
that's one of the reasons why you take out the water by adding the concentrated spelling or heat test before.
to stop the reaction.
Stop it being reversible.
Well, to move the equilibrium.
Yeah, to stop
If
the
it
reaction.
basically
'Cause in
that-
technicality, it's always it's always reacting per se.
Mhm.
It's like osmosis.
But then basically,
there's no net movement, but it's still happening.
See, that is
but
it.
then there's a point where if you take out enough water, it'll stop the reaction.
Yeah, that's the thing.
You'll
Yeah,
be able to come back.
can't do anything else.
Okay, so if I decrease my carbon monoxide concentration, it moves the equilibrium position to the
Left.
left. Get to replace the carbon monoxide that I have removed. And so that has a result of
Decreased yield.
decreased yield.
Excellent.
Okay, there's a summary of your concentration changes, and if this does seem to, I think the best way is to have LCP in your head and be able to apply it to a given situation. But if you're struggling with that, these 4 statements, they'll never let you down. Okay, so if we increase the concentration of a reactant, where does the equilibrium move?
Right.
To the right. If we increase the concentration of an, how I wrote that was just RHS, right hand side. You'll see me use that from time to time. What if we decrease the concentration of reactant? Moves to the left hand side. If we increase the concentration of a product,
Left.
left, because we want to remove that product. And then if we decrease the concentration of a product,
RHS.
RHS, a bit like our esterification. Fabulous.
Wait, what?
No.
Oh.
I thought it was RHS.
Yeah, right hand side.
Okay, second effect is pressure, and the effective pressure only applies to the
I
effective.
thought it was like some chemistry term.
The effective pressure only applies to equilibrium reactions that are in homogeneous gaseous phase. Pardon?
Homogeneous.
Homogeneous. Okay.
Like a walk into the silver you are.
I know my Latino. Excalibur.
Okay, and basically what that means is that all our reactants and our products have to be gases. If they're not, then pressure doesn't really have an influence. Now, we have not done this moles calculation, but I can tell you the 1 mole of any gas, be it oxygen, nitrogen, fluorine, argon, helium, you get the point, all of it, 1 mole of any gas occupies the same volume, and that volume is 24 decimeters cubed. So 1 mole of any gas occupies 24.
But like, what if they're bigger? Do you know what
They're
I mean?
not.
No, they're not big.
1 mole of gas equals 24 decimeters cubed. It's just the way it is. Okay, and what we'll do when we get to this calculation is that volume equals N times 24. Basically, that means if I have 2 moles of gas, that my volume is going to be 48 decimeters cubed.
Is this to do with that gas constant on the thing?
It is honestly very clever.
Care about, like,
I could do.
Is iodine not bigger than chlorine, for example?
Yes, but the space it takes out, so the iodine molecules will be bigger,
So why can they
but
all-
there'll be
why-
like just less space between them.
Why?
Because of Van der Waals.
No, but surely, like in the same space, you can get more weak chlorines and the
Nope.
No, it doesn't make sense.
It doesn't.
It doesn't make sense.
You have knowledge, so you
It
don't
doesn't
know.
make sense.
How does it
Which
make sense?
iodine's a larger molecule, yes.
Yeah, so you can get less in
But
it.
right, so say there's an iodine there and there's an
Right.
iodine there, right? Actually, no, there's one iodine. It says no molecule. No,
Right, okay, right.
Right. These are bigger molecules, so there's a longer bond. But
Yeah, you can put like 10
because
chlorines.
because they're bigger, they've more Van der Waals, so then like 2 of these would stick closer together. So then
Oh,
overall
the
it would
Van der Waals, miss. I get
it would sort of net out and sort of be like
I get
zero.
it.
Great, so 1 mole of any gas occupies 24 decimeters cubed.
But then could you
I
not
feel that
cram
there's-
like
the-
more
I feel
smaller
that
ones
there's
in
many
together because they're
exceptions
not
to
as
that
strong?
rule.
Yeah, but
Yeah,
it
just
all
like push
cancels
them
out,
together.
like the ratio of big to bond or proportionality and whatnot.
Okay. And so what we know is that the more molecules of gas present, what happens to our pressure?
What?
If we have more molecules of gas, what happens to our pressure?
It increases.
It increases. So more molecules of gas in a given space
You would have
increases our pressure. And so what we find is that if we have
Ross has finally lost it.
a homogeneous gaseous equilibrium, for example, the one that we just looked at,
Get a coordinating close, you know.
if we increase the pressure, the equilibrium will favour the side of the equilibrium that has fewer gas molecules. Because, say for example here, on the left hand side, how many molecules of gas do we have?
48.
2. We've one of carbon dioxide
48
and one of...
DM cubed.
Yes, lovely. So we say that we have 2 volumes of gas here. What about on the right hand side?
Pardon?
What about on the right hand
One
side?
volume.
1 volume. And you need to take into consideration your balancing number. So say that had been 3 COCl2, that would have been 3 volumes of gas. Okay? And so if I increase the pressure of my system, LCP tells me that the equilibrium shifts in order to decrease
Just a minute.
the effect of that change. Okay, if I shift my equilibrium to the left hand side, can you see that I'm producing 2 volumes of gas?
I can.
And so that is going to have the effect of increasing the pressure further because I'm just getting more and more molecules of gas.
Think about it.
Whereas if I moved it to the right hand side, what am I doing?
Increasing the whole volume.
Yeah.
There's 2 bodies on the side, so the balance out a bit more.
Yeah, exactly. I'm producing fewer gas molecules than more.